Today we're going to talk about the metric system. First, we're going to start with units. Some of the basic units we're going to use to deal with measuring mass, volume, length, time, temperature, and energy. For grams, we use grams for mass, we use liters for volume, meters for length, seconds for time, we do Kelvin for temperature, and joules for energy. So you've probably learned your metric conversions before, where you learned how to move the decimal, and you had to learn all of the different conversions within the metric system. You had like King Henry and some little rhyme that helped you to remember that. Well, we only need to learn 5 conversions. So instead of having to learn all of them, we're just going to learn 5. So we need to know kilo, centi, milli, micro, and nano. Now micro has a different kind of unit or symbol for it than you're used to seeing. And that is really a U with like a tail or a trunk in front. It's called a mu. Alright, so you will need to learn these conversions. So a kilogram is a very large unit. Therefore, there's 0.001 kilograms for every 1 gram. Now, all of these conversions will be true if we exchanged out gram for meter, liter, seconds, or joules. We can interchange those. I'm just using grams as our example here. The prefix centi means 100. Okay? And so 100 centigrams is equal to 1 gram. Milli is 1,000. So we have 1,000 milligrams for 1 gram. And then we have micro, which is 10 to the 6th. Micrograms for 1 gram, or 1 and 6 zeros. And then we have nano, which is 10 to the 9th, nanograms for 1 gram, or 1 and 9 zeros. Now personally, I don't like to count that many zeros, so I'll use scientific notation for micro and nano. Typically, I like to use scientific notation for any numbers 10 to the 5th and greater. Let's look at some problems. We have 54 grams. How many centigrams would that be? Now, many of you can do these in your head, but we're going to use factor label method in order to solve these problems, which is a method we will be using all throughout chemistry. So we have 54 grams. Now, what is the conversion, or how are centigrams and grams equal to each other? Well, we know that 1 gram is equal to 100 centigrams. So we can create what's called a conversion factor with that. And we use the conversion factor to cancel out our units to get the unit that we want. So since we no longer want grams, we'll put it on the bottom. The unit we do want, we'll put it on the top. Okay? And since both of these two things here are equal, we put in how they're equal. So 100 centigrams is equal to 1 gram. This is just like multiplying. So you multiply across the top and divide by things in the bottom. So in this case, we're going to take 54 times 100 divided by 1. So 54 times 100 gives us 5,400. So this would be 5,400 centigrams. Number 2, we have 6.23 times 10 to the 5th microliters. How many liters is that? So again, starting with the information we're given, 6.23 times 10 to the 5th microliters. Again, the unit we no longer want up on the bottom, the unit we do want up on the top. Then we put in how the two are equal. 1 liter is 1 times 10 to the 6th microliters. And so in this instance, we're going to divide. 6.23 times 10 to the 5th divided by 1 times 10 to the 6th. Now you can either plug this into your calculator, or if you remember your rules for dividing exponents, when you're dividing your exponents, you subtract them, right? So 5 minus 6 would be a minus 1. So you can write the answer as 6.23 times 10 to the minus 1, or you could write it as 0.623. Either of those would be correct. Now number 3 is a little bit more difficult. It does not go to or start with a base unit. So we're going to start with our 0.75 kilometers. So I'm going to do this one down here. It's going to take a little more room. Okay. Again, I no longer want kilometers, so I'm going to put it on the bottom. Now I don't like to learn too many different things at once. So I just know what my conversions are to the base unit. So I'm going to do this in 2 steps since I know how kilometers are equal to meters. I'm going to just go to meters to begin with. And I know that 1 meter is 0.001 kilometers. Now I can change my meters, since they're on top here, up on the bottom, into nanometers. Nanometers up on the top. So again, how are those equal? Nano is 1 times 10 to the 9th, and meter is 1. So again, multiply across the top and divide by what's on the bottom. So again, you can plug that into your calculator, or you could do it in your head, because this is the same as 1 times 10 to the minus 3. So 10 to the 9th minus a minus 3 would be plus a 3. So 9 plus 3 is 12. And so then we'd have to move this one place, and so you'd have 7.5 times 10 to the 11th nanometers. Or like I said, you can plug it into your calculator, multiplying what's on the top and dividing by what's on the bottom, and you will find you'll get the same answer as I did. 7.5 times 10 to the 11th nanometers. Okay. So now it's your turn to try some on your own. And we'll do some more practice in class tomorrow as well. So here are 4 problems for you to try on your own. I'm going to go ahead and pause the video so that you can work on these problems. And then restart the video and you can check your answers. On the next board, I've provided you with not only the answers, but also the work on how I got them.